Question number 28. An object weighing 4 newtons swings on the end of a string as a simple pendulum. At the bottom of the swing, the tension in the string is 6 newtons. What is the magnitude of the centripetal acceleration of the object at the bottom of the swing? So what we want to do is you want to find centripetal acceleration in terms of g, because that's what the answers give us. So let's draw what's going on. So we have mysterious object at the end of a string, and because it's a pendulum, it's going in a circular path, roughly. If we draw the forces on here, we have the weight force and we have the tension force. We sum our forces, we have the net force is equal to the tension force minus the weight force, which is equal to mass times acceleration. We solve for acceleration and we get acceleration is equal to the tension force minus the weight divided by the mass. Now we don't have a value for mass, but we have a value for weight. So what we can do is we know that the weight force is equal to mass times g. We solve for mass and we have mass is equal to the weight force divided by g. If we plug it into our original equation, we have acceleration is equal to the tension force minus the weight force divided by the weight force divided by g. Now we can start plugging numbers into this. So we have acceleration is equal to 6 newtons minus 4 newtons divided by 4 newtons divided by g. I'm not substituting 9.8 meters per second in for g because we want our answer in terms of g. So we start solving for that. Acceleration equals 2 newtons. I'm going to bring the g to the top of the fraction times g divided by 4 newtons. The newtons cancel out, so we have acceleration is equal to 1/2 g, or 0.5 g. We look for that in our answers. The answer is A. We circle it, and we're done.